the universe is a vast, mysterious place that has captivated the human imagination for centuries. From ancient civilizations to modern-day scientists, humans have always sought to understand the cosmos. As we look into the night sky, we see a beautiful expanse filled with stars, galaxies, and mysteries that continue to elude us. Over the centuries, our understanding of the universe has evolved tremendously. Theories about the stars, planets, and galaxies have been proposed, tested, and refined, with each discovery adding another piece to the puzzle. However, in recent years, some groundbreaking revelations have made scientists reconsider long-held beliefs, especially with the advent of the James Webb Space Telescope, JWST. What seemed like a well-established understanding of the universe is now facing profound challenges. As we dive deeper into these new developments, we realize that our view of the cosmos is undergoing a revolution, one that may change the way we think about everything from the Big Bang to the very nature of dark energy. For most of the 20th century, scientists relied on a cosmological model that was first formulated in 1922. This model was based on the groundbreaking discoveries made by scientists like Albert Einstein, Edwin Hubble, and Georges Lemaitre. It provided a coherent picture of the universe that helped to explain everything from the expansion of the cosmos to the origin of galaxies. This model laid the foundation for modern cosmology and has been the cornerstone of our understanding for nearly a century. However, recent discoveries have shaken the very pillars upon which this model was built, forcing scientists to reevaluate their assumptions and rethink some of the fundamental aspects of the universe. Professor Seir Sakar, a prominent astronomer and cosmologist at Oxford University, has been at the forefront of this discussion. In his recent remarks, he pointed out that while the work of early cosmologists was invaluable in advancing our understanding of the universe, the theoretical foundations upon which they built their models are now outdated. He emphasized that modern observations are revealing discrepancies that suggest that the universe is far more complex than we once thought. One of the most significant revelations, according to Sakar, is that the universe may not be homogeneous, that is, it may not look the same in all directions as we once believed. This is a fundamental assumption of classic cosmology, and it is now being called into question. The homogeneity of the universe is a key concept in the standard cosmological model. For decades, scientists have assumed that the distribution of matter and energy in the universe is the same in all directions. This assumption, known as the cosmological principle, suggests that the universe is largely uniform on large scales. The belief in homogeneity has shaped much of our understanding of the universe's evolution, from the Big Bang to the formation of galaxies and galaxy clusters. However, the latest data from the James Webb Space Telescope challenges this assumption in a profound way. The JWST, launched in the summer of 2022, has provided astronomers with a new and more detailed view of the universe. Its advanced infrared capabilities allow it to peer deeper into space than ever before, revealing structures and phenomena that were previously invisible. One of the most surprising findings from the JWST is the discovery of massive structures in the early universe that appear to defy the notion of a uniform distribution of matter. These structures, which include large clusters of galaxies and unusual distributions of quasars, suggest that the universe may be far more complex than the traditional cosmological models have led us to believe. Quasars, for example, are incredibly luminous objects that are found at the centers of distant galaxies. They are powered by supermassive black holes and are among the most powerful sources of energy in the universe. According to the standard cosmological model, quasars should be distributed evenly across the cosmos. However, observations from the JWST have shown something very different. In fact, the density of quasars on one side of the universe is about 5% higher than on the other side. This uneven distribution of quasars is a clear challenge to the assumption of homogeneity in the universe. Another groundbreaking discovery made by the JWST is the identification of two massive cosmic structures that were previously considered impossible. These structures, known as the Great Ring and the Giant Arc, are so large that they seem to defy the laws of cosmology as we understand them. The Great Ring is a vast structure formed by a group of 9 gamma-ray bursts that are roughly equidistant from Earth. With a diameter of about 5.6 billion light-years, it is one of the largest known structures in the observable universe. The problem with the Great Ring is that it challenges the standard cosmological model, which predicts that on scales larger than about 1.2 billion light-years, the distribution of matter in the universe should be uniform. The Great Ring, however, is anything but uniform. Its sheer size and complexity defy the expectations of classic cosmology. The giant arc is another structure that raises questions about the homogeneity of the universe. This arc consists of a nearly uniform alignment of galaxies that spans about a tenth of the entire observable universe. This is an astonishingly large structure, and it challenges the cosmological principle that the universe should have no preferred directions or regions of higher density. The discovery of both the Great Ring and the giant arc has forced cosmologists to reconsider their understanding of the universe on the largest scales. These structures are not just outliers, they are massive cosmic phenomena that cannot be ignored. For years, astronomers have been aware of irregularities in the distribution of galaxies and other cosmic structures. Even the Hubble Space Telescope, which has been a cornerstone of modern astronomy, regularly provided data that didn't quite fit the standard cosmological models. However, these irregularities were often considered to be outliers, anomalies that didn't necessarily challenge the overall framework of cosmology. The saying exceptions prove the rule applied here. These outliers were seen as exceptions to the general trend of cosmic uniformity. But as more and more anomalies have been discovered, it is becoming clear that these irregularities may be more than just exceptions. They may represent a new reality that forces scientists to rethink the very foundations of cosmology. One of the most significant challenges to the standard cosmological model is the question of dark matter and dark energy. These two mysterious substances are believed to make up about 95% of the total content of the universe, yet they remain invisible and undetectable by conventional means. Dark matter is thought to be responsible for the gravitational effects observed in galaxies and galaxy clusters, while dark energy is believed to be responsible for the accelerated expansion of the universe. Despite their importance, neither dark matter nor dark energy has been directly observed. Instead, their existence is inferred from their gravitational effects on visible matter. In the standard cosmological model, dark matter and dark energy are assumed to be evenly distributed throughout the universe. However, the discoveries made by the JWST suggest that this may not be the case. The irregularities observed in the distribution of galaxies and quasars seem to contradict the idea that dark matter and dark energy are uniformly spread across the cosmos. These new findings challenge the very assumptions that have underpinned our understanding of the universe for decades. The implications of these discoveries are profound. If the universe is not homogeneous, it could fundamentally change our understanding of how the universe works. For one, it would suggest that the universe may have regions of higher or lower density, which could alter the way we think about the formation of galaxies, stars, and even life itself. It could also mean that the laws of physics as we understand them may need to be revised. The traditional models of cosmology may no longer apply on the largest scales, and new theories may need to be developed to explain the unexpected findings from the JWST. The discoveries made by the JWST have also led some scientists to propose more radical ideas about the nature of the universe. One of the most intriguing possibilities is that the universe may have some form of intelligence. While this idea may sound far-fetched, it is based on the surprising new data that suggests dark energy may not be as constant as once thought. Dark energy is believed to be responsible for the accelerated expansion of the universe, but recent data from the Dark Energy Spectroscopic Instrument, DESI, shows that the properties of dark energy may have changed over time. This could imply that dark energy is not a simple, unchanging force but may have some kind of dynamic or even intelligent properties. If dark energy is not constant, it would suggest that the universe is not a static, unchanging entity but a dynamic and evolving system. This idea is still in its infancy, and much more research is needed to fully understand the implications of these findings. However, it is an exciting possibility that could lead to a radical shift in our understanding of the cosmos. In many ways, the discoveries of the JWST represent a turning point in the history of cosmology. For nearly a century, scientists have built upon the work of pioneers like Einstein, Hubble, and Lemaitre, using their models as the foundation for our understanding of the universe. But as we move into the 21st century, it is becoming clear that those models are no longer sufficient to explain the complexity of the cosmos. The discoveries of the JWST are forcing scientists to rethink everything they thought they knew about the universe, and it is possible that the cosmological theories of the future will look very different from those of the past. The excitement and uncertainty surrounding these discoveries are palpable. The world of cosmology is at a crossroads, and the next few years could see some of the most profound shifts in our understanding of the universe since the days of Einstein and Hubble. For those of us who are fascinated by the cosmos, these are truly exciting times. The universe is still full of mysteries, and with the help of the JWST and other advanced telescopes, we are only beginning to scratch the surface. The future of cosmology holds great promise, and it is impossible to say what new discoveries lie just around the corner. As we look ahead, one thing is certain: our understanding of the universe will continue to evolve. The groundbreaking work of the past will always be a part of the story, but as new data comes in and old assumptions are challenged, we are entering a new era of exploration and discovery. The universe is not what we thought it was, and the best part is that we are just beginning to uncover its secrets. Whether or not we are ready to accept it, the truth is that our old theories are being replaced by new ideas that may revolutionize the way we understand the cosmos. The future of cosmology is bright, and the journey of discovery has only just begun.